Artificial intelligence, or AI, is about building machines that can perform tasks requiring human-like intelligence, problem-solving, learning, and understanding language. Rather than a single technology, AI is a broad field, ranging from simple calculators to complex systems that perceive and act in the world. Early AI relied on hand-coded rules, if this, then that, but these systems struggled with real-world complexity. Today, AI spans a spectrum. Narrow AI handles specific tasks like movie recommendations, while general AI, machines with human-level adaptability, remains a distant goal. The field has evolved from rigid rule-based systems to more flexible, data-driven approaches. The central question, can we replicate intelligence outside the human brain? This quest led to machine learning, where computers learn patterns from data instead of following explicit instructions. Machine learning, in turn, gave rise to an even more transformative technique. This new approach allows machines to learn directly from vast amounts of data, discovering rules on their own. And that's where the story of deep learning begins. Machine learning marked a shift. Machines now learn from data, not just rules. We feed computers huge data sets, letting them find patterns and make predictions, much like a student learning from examples. This leap freed us from writing rules for every scenario. Deep learning, a powerful branch of machine learning, takes inspiration from the human brain's structure. It uses artificial neural networks with many layers, hence deep. Each layer processes information, building up from simple features to complex concepts. For example, to recognize a cat, early layers detect edges, later ones assemble shapes, and final layers identify the cat itself. Deep learning learns these features automatically, without human guidance. This automation sets it apart from earlier methods, which required manual feature selection. As a result, deep learning has achieved breakthroughs in image recognition, language processing, and more. It's revolutionized what machines can do. AI is the broad goal, creating intelligent machines, while deep learning is a specific, powerful method within that universe. Not all AI uses deep learning. Classic chess programs, for example, rely on rules, not neural networks. Traditional AI often depends on structured data and explicit logic, while deep learning thrives on massive unstructured data sets, images, audio, text. Deep learning's intelligence emerges from patterns in data, not from human-written rules. It requires far more data and computing power than earlier AI methods. The rise of big data and powerful hardware made deep learning possible. Another key difference: transparency. Rule-based AI decisions are easy to trace. Deep learning models are black boxes, making their reasoning hard to interpret. This opacity raises new challenges for accountability and trust. Understanding these differences is crucial as AI becomes more embedded in our lives. AI is everywhere, from navigation apps calculating routes to email filters blocking spam. Recommendation engines on streaming platforms use AI to suggest what you might like next, based on patterns in your behavior. These systems often rely on machine learning, finding correlations in data to make predictions. Deep learning powers more advanced features. Voice assistants use deep neural networks to understand and respond to your speech. Face Unlock on smartphones relies on deep learning to recognize you in any light or angle. Social media platforms use it to tag friends in photos automatically. Deep learning can even generate new images or captions from scratch. These capabilities, once science fiction, are now part of daily life thanks to deep neural networks. The difference: deep learning handles complexity and perception in ways earlier AI could not. Knowing the difference between AI and deep learning helps us make sense of today's technology. It lets us ask, is this a step toward general intelligence or a clever use of data-driven learning? For businesses and policymakers, clear understanding prevents confusion and wasted resources. It ensures the right tools are chosen for the right problems. Ethically, it helps us address bias and accountability. Rule-based AI reflects its programmers, while deep learning can hide biases in data and decision-making. As AI shapes our world, demystifying these terms empowers us to engage thoughtfully and responsibly. We can celebrate deep learning's achievements while keeping sight of the broader quest for true AI. In this technological journey, understanding these distinctions is our essential first step.